All right, good morning. My name is Alia. This is Guilherme and Craig, and we're here to introduce our app. Our app is called the PositiveSnake game. I am a Montessori teacher. Montessori is a method of education where students learn in a classroom through hands-on materials. One of the staple math materials that are presented in a Montessori classroom is called the colored bead stair. This is here on the right. Each color has a number association. So red is 1, 2 is green, and it goes all the way down where you can see here dark blue is equivalent to the number 9. So what does this mean for the game? This means that those colored bead stairs help the children practice their addition facts. The whole premise of the game is to create tens, finding tens. And this is important because when we are young, as children, we learn that it's easier to count by tens. And we often go through this process 10, 20, 30. So this game allows children to use addition facts to make groups of 10 in order to help them learn how to add. In this game, in the classroom, a child will create a snake with the colored bead stairs and then make a shift change to a golden bead. One of the premises of Montessori is something called control of error. Maria Montessori says that children should learn independently and it's okay to make mistakes. Hence this control of error that happens in the classroom when they play the game and hopefully when they use it on the application. This is an example and demonstration of a person in the classroom and how they would play the game. There are 3 components here. The colored bead stair, which I just showed you, the 10 bars, which represent the 10, and over here we have something called black and white remainder bead stair. This is used as a placeholder or remainder in the actual game, and this will be shown while this individual plays the game. So first thing they do is they make the snake, and in this case he's used these beads to create the snake. The second piece is you begin counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that this individual has hit 10, they put a little placeholder there. And when they think 10 and they count to 10, they swap out for a golden 10 bead. But what happened here was that this colored bead was still associated with a part of the 10. So therefore, they counted 5 remainder and are using the black and white bead stair to act as a placeholder so that the child remembers there is still 5 to count. Then you discard of the 2 beads that have already been used and replace them with the golden bead and the black stair. From here, you continue to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this case, we have a perfect 10, and the 2 beads get swapped out for another gold bar. And essentially, that's how the process goes until you get numerous 10s and any remainder. So why an application? It's really important to reinforce the use of Montessori materials outside of the classroom, but at the same time, they're very expensive. So this app allows children to practice their addition facts in a way that complements what they've already learned in the classroom outside in their homes using the Montessori beads and learning how to make 10.
Thanks. So from our perspective of programming this game, we found that games involve different interactions than other apps. We have to have things moving on screen. And also we felt we had to be true to the apper and also Montessori's ideals of how to play the game. So we had a long period of experimentation to figure out how to do the layout. And we ended up doing this with something called SpriteKit. It's a 2D framework. And then behind the scenes, we also had to create a bead store to create the beads in the game and keep track of them. And the counting logic, keeping track of the count and adding up, and maintain the state for a confirmation screen. Next, we're going to show you our app version. Here's the app. Guilherme is going to be a child, and I'm going to tell you what he's doing. First of all, you can see on the playing surface we have the beads on sort of a bench up there that the child can select. The brown part is the mat, the playing mat. And by tapping on a bead, you can put it onto the mat to build up a snake. So Guilherme is choosing blue and red and brown. The snake goes up and down automatically as he chooses these. He can choose whichever colors he likes, and then he made a mistake, so he's going to restart. That's possible as well.
And it's important to make sure that you realize that the color is also associated with the number. So for example, he began with blue, and blue represents 9. And as the child goes through the Montessori program, they memorize the color association with the number.
And these are the same colors that were on the video that she showed previously. Now he has the snake made up, and by clicking at the top where it says count, he can go to the check screen, and then, as in the video, tap on each bead to count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
He did it, so he can tap a gold bead to swap out. Nice counting, Guilherme.
Thank you. Now we're starting up. Count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And swap for a gold.
And now there's 2 gold beads at the top, so of course this is 20.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
In these cases, Guilherme is doing pretty good counting. He might not always be so good. If he thought it was 10 but it wasn't, a 10 will still go up there.
So
Part of the Montessori method is self-correction. So now, at the top there's a check button. He can click on the check to find out if his counting is accurate or not. And here, there's the gold beads lined up with a space beside them. And these are the colored beads that he used. So he can choose those to try to place beside the 10s to make sure there's perfect 10s with none left over. Did he do it?
And this is also similar to the control of error. So if he had miscounted, while he's checking his work, he would realize that, oh, I made a mistake, that I need to do it again.
Good job, Guilherme.
So, as future work, we have several suggestions. The first one would be introduction of different activities and lessons as flashcards, for example. Also, the application could be smart enough to suggest different exercises according to the profile of the kid, of the child, and changing the difficulty level of those activities. We could introduce also some kind of cloud platform in order to provide, or in order to connect teacher to the children, providing synchronization of homework assignments and so on. Well, learning. It was a really good experience because Craig and I, we had already some experience developing iOS apps, but game is completely different. And we can take from this experience here something as the difficulty of capture the essence of a gameplay, and also to identify the correct balance between verisimilitude and usability in your application. Also, the proof of concepts are not conclusive, not always. We perform several proofs of concepts in the beginning of the application before starting the development, trying to choose the best framework, the best game engine framework. And we were not able to oversee all the problems that we had during the development. And it was really hard to work in a closed platform as iOS and SpriteKit. Those are not open source frameworks, not open source platforms. And it's very difficult to tweak that in order to make it behave like we want it. Questions?
Thanks for your attention. Questions?
For the last part where you check the beads against the, so if you break up like a series of beads because you have a remainder, how does that match?
So the beads themselves cannot be broken, which is why you have that remainder. So at the end you saw that there was a remainder of 3, so the black stair was still represented here to show the remainder. But if the child didn't match up 10, for example, you couldn't put it together. So for example, in the first row there,
This one might be split in half, but
because 2 is green, but you couldn't put it one of those greens with the blue because they don't break apart.
So what happens if the child thinks they've reached 10 and then they try and swap?
They can.
They can, and then at the end they realize that they messed
They
up.
may really hit 9, they think it's 10, and they click swap,
Mhm.
and they continue along. So when they get to this screen, things just won't add up, and then they have a self-check, and they can understand they screwed up back there somewhere. Yes, they do it again.
Okay, thank you.